This is reviewing for Unit 1, the Unit 1 test. First we're going to go over the different types of numbers. So we have rational numbers, irrational numbers, integers, whole numbers, and counting numbers. It's easiest to start with irrational numbers, which are things that don't end, so decimals that don't end, and there's no pattern. So things like pi, or 0.12, 112, 1112. Alright, these things don't end, so they're irrational. Now, rational numbers are numbers that do end, that or have a pattern. So even 1/3, which when you express as a decimal is 0.33 repeating. Okay, that's a rational number. This includes all fractions, so you could even have 1/4, the number -2. Those are all rational numbers. Integers are all numbers, even negatives, that are not fractions or decimals. So -1, 0, 1, 2, those are all integers. Whole numbers are numbers like 0, 1, 2, 3. Notice we have no negative numbers. They're all positive, and they don't include decimals, don't include fractions at all. Counting numbers start at the number 1 and then go up. 1, 2, 3. And you can remember counting numbers because if you're counting things or you're counting people, we never start with 0. So the whole numbers start with 0, but counting numbers does not include the number 0. Okay, moving on. Let's go over some properties. The first one I'm going to do is additive identity. And that is when you have a number, like the number 4, and you add 0 to it, and you get the same number that you started with. So think of it as, this is how you'll notice it, that there's a 0, or that there's a plus, and that there's also a 0. Okay? So that will clue you in that it is additive identity. Multiplicative inverse deals with multiplication, so I'll put a dot. And you have a number 6, for example, and you multiply it by the inverse. So the inverse of 6, which is 6/1, is 1/6. And when you multiply those two together, you're going to get the number 1. Okay? And that's always true for multiplicative inverse. Okay, commutative property. Commutative property is when you have numbers in an equation form and you switch them around. So 3 plus 4 plus 5 equals 4 plus 3 plus 5. Now I have the same, my answer would be the same either way, but see how we switched the 3 and the 4? So commutative, change order, that's CO. That's how you know commutative. Now associative property is similar, but you'll know it because the numbers stay in the same exact order. So 3 plus 4 plus 5 equals 3 plus 4 plus 5, but here you'll notice that the parentheses are the thing that change, the numbers within the parentheses, but the order itself stays exactly the same. So that is the associative property. Additive inverse, again, you'll know this one because, okay, it has a plus. And the inverse of something is the opposite, right? So we're taking a number like 2 and we're adding -2. We're adding the opposite. So 2 plus -2 equals 0. So whenever you have the additive inverse, your answer is going to be 0. Multiplicative identity. Kind of like additive identity, you're going to be multiplying something by a number in order to get itself. So any number times 1 is going to equal itself. Alright, moving on. Okay, now we're going to solve some equations for x. The first one that we'll do, you'll notice we need to do a little distributing right here. I'm just going to draw my arrows, and I'm going to bring everything down and do my distribution. 10x minus 3 times 8 is 24. And -3, notice that negative, times -5x is a positive 15x. Equals -74. Okay, I can combine like terms right here and right here, which gives me 25x minus 24 equals -74. Now I can start moving things. So I'm going to go ahead and do my addition property of equality and add 24 to both sides. Cancel that out. 25x equals -50. And the last thing I do is I divide by 25 because I'm trying to get x all alone, and that's what's left. So my answer is x equals -2. Okay, let's try another one. Again, parentheses tell me, oh, I need to distribute. And look, it's happening on both sides this time. 2 times 20 is 40. 2 times -6x is -12x equals 8 minus 4 times 3x is 12x. And -4 times -8 is positive 32. Alright, I'm going to combine some like terms. This 8 and this positive 32. Bring everything else down. 40 minus 12x equals 40 minus 12x. I'm noticing something important here. Plus 12x on this side, plus 12x on this side. Oh look, they both cancel out. So 40 equals 40. I don't have any x's left because they all canceled out. So this means that I have to check my answer here. 40 equals 40, and I have to ask myself, is that true? Yes, that is true. 40 always equals 40. So in this case, we have infinite solutions. So x could equal anything, any number. Okay, so for this one, we are going to solve the equation, but we're also going to use words to justify each step. So I have my original equation, and then the very first thing I do is the distributive property. 8x plus 28 equals 108. Okay, and we just said this is the distributive property. Okay, I would combine like terms, but I don't have any like terms to combine. So I am going to get right to solving. I'm going to take 28 away from this side and 28 away from this side. Those are going to cancel out. This is called subtraction property. I'm going to abbreviate that. Of equality, because we did it to both sides and we subtracted. So subtraction property of equality. It equally occurred. Okay, so those crossing out that I did is going to leave me with 8x equals 108. And that was additive inverse, because if you noticed, we did a positive 28 minus 28, which gave us 0, right? So that was additive inverse. Now we need to get x all alone. 8 and x are glued together, and we can only separate them by dividing. 8 divided by 8 is going to be 1. It's going to leave me with x. Oh, you'll notice, look, I forgot to subtract up there, didn't I? 108 minus 28 is going to give me 80. So x is going to equal 10. Now, this property that I did was the division property of equality, because we divided on both sides by the same thing. And then at the end, we did the multiplicative inverse in order to get our answer of x equals 10. So there I've solved an equation and I've justified it with different properties. Okay, let's take our solving of equations and turn it into solving inequalities. We're going to use the same ideas that we did for equations. So in this case, I see parentheses and I say, oh, I need to distribute. So I'm going to go ahead and do that. Negative 8x minus 2 times 2x is a negative 4x. And negative 2 times 3 is negative 6. Is less than or equal to 4. You can combine like terms here and here. Negative 8 minus 4 is negative 12x minus 6 is less than or equal to 4. You can add 6. See, it's just like solving an equation, just without the equal sign. Instead, we have an inequality. Okay, so here's where things get a little tricky. Notice if I divide by just regular 12, I'm going to get negative x, and that doesn't fly. You can't have negative x. So we need to divide by negative 12. And, very important rule, if you divide by, oh, these should be in red. If you divide by a negative number, you need to flip your sign. Okay, so I'm flipping my sign. Instead of the little n pointing toward the x, I'm now going to have the big N pointing towards the x. And I'm going to go ahead and simplify my 10 over 12 to negative 5/6. Okay, now if we're going to put it in interval notation, this is how we do interval notation. I have to think about the smallest point and the largest point that x could equal. So I'm going to go ahead and read out loud my solution, which is x is greater than or equal to negative 5/6. Okay, so in my head I'm thinking, what's the smallest point that x can equal? Well, the smallest point x can equal is 5/6, because I said x is greater than negative 5/6. So the smallest it can equal is negative 5/6. Now, can it equal it? Yes, it can. So I put this end in brackets. And I put a comma. What's the biggest number x can equal? Well, I don't even know. It could be infinity. So I'm going to put infinity. Now, whenever I use an infinity, I have to close it with parentheses and not a bracket, because it's an unknown number, it's really high, right? So we always close it with a parenthesis. So that's interval notation for my answer. All right, last slide. So this is something new that we did, and it is called literal equations. So for the first one, V equals LWH, I'm going to solve for H. So if I'm trying to get H all alone, L, W, and H are all glued together. So this means that I need to divide to get them apart. And I'm going to divide by both L and W. They're glued together. I could take them away together. If I do it to one side, I have to do it to the other. So my answer is V over LW equals H. The next one, E equals MC squared. I'm solving for C. Okay, so my M and my C are glued together. My M and my C squared. So I'm going to divide by M on both sides. So I have E over M equals C squared. But I have not gotten C all alone. I still have that squared. So I have to think, what is the opposite of squaring something? Because that will get the C all by itself. The opposite of squaring something is taking the square root. The square root looks like this. So I need to take the square root of both sides. So the square root of E over M equals C. Because once you do the square root, you get rid of that squared next to the C. So there's your answer.